You've been there
You
for
see that?
hours.
It could be a feature.
Best one.
Sorry, Mike.
Okay,
I did see it.
thanks for coming along. As you know, April is 3D printer month. Hang on, let me just stop that. I'm hearing myself come back. And so we had the forum night last week, which I've watched that video a few times and some fantastic input. And in fact, we've got, wherever he is, Richard, be doing possibly a little thing at the end, follow-up questions. So thank you, Richard. We've got Praj, VK4MPB, VK7MPB, and also Curie, VK7KLB, 4KLB. Welcome, and soon to be a permanent Tasmanian residents.
It all depends on the building industry.
So Praj has agreed to come along and give us a 3D printing spectacular. Now, I'm not going to try and describe what Praj has done in this space because it's huge, and he'll do all that. So, without further ado, across to Praj.
Thanks, Justin. No pressure, guys. Oh well. If I can flip over to.
Oh, yeah. Now that's a.
Let's see if that'll work. That is AI generated. That is kind of a really clean version of my desk.
Complete with snake.
I have a snake.
Cool.
We also have chickens. And no, I'm not going to show you a photo of my real desk. It looks worse.
Does the snake eat the chickens?
I'd be more concerned of the chickens that eat the snake, because our chickens are bossy as, and they rule the place. We live there by their sufferance.
They're cats with wings, then, basically.
Well, they beat up the neighborhood cats.
Ouch!
Yeah. You're talking 5 kilo chooks.
Yeah.
So 3D printing. What is 3D printing? As I said, it's just material deposition, really. You start building layers one on top of the other. If you could draw a line, put a bit of glue on it, draw another line on it, put a bit of glue and draw another line, and start building up layers. And the technical term you'll run across is something called additive manufacturing, because you're literally adding things to manufacture a product. I like to think of it as building objects layer by layer from a digital model. I assume we're all familiar with
Yep.
replicators.
Mhm.
That's what got me into 3D printing. I don't have the examples up here, but I can tell you right now, you can go look up NASA's plans for a pizza 3D printer. You can also go look up a Kickstarter that succeeded, shipped to about 2,000 people back in 2013 for a pancake 3D printer. It would make whatever shapes you want on a lovely hot bed, and then flip it over and you've got a pancake. Whatever complex shape you want.
Wow.
So a couple of other terms that I want you guys to familiarize yourself with if you're not familiar with is SLA, stereolithography, SLS, selective laser sintering, and FDM is fused deposition modeling. Now, I'm going to tell you the same thing I tell my students. In science, we like to use fancy words. Stereolithography, two-dimensional light writing, literally, you translate from Latin. Selective laser sintering, you're using lasers to selectively melt and fuse things. So stereolithography is when you use resin, liquid, cure it into a solid by using UV. The cheap way is to take a screen, put a black mask on it, only open up the mask where you want the light to come through in the shape you want to come through, shine UV, boom, you've got hardened stuff in that shape. Fancy way is to have a laser trace it. Don't have the money for one that actually traces lasers, so I only have the one that does the UV screen. SLS is super fancy. You get a bed of powder, usually nylon. A laser goes through in 3 dimensions, reflected using a whole series of mirrors, and builds a 3D model inside that bed of nylon. You can do incredible things with it.
Is this an out of a solid thing?
Nope, it's, imagine a giant vat filled with nylon powder. And you've got a laser going in with mirrors all around it, sort of pushing the beam to exactly where it needs to go. It reaches focus at one particular point where it melts the nylon and hardens it.
Yeah, perhaps I'm not understanding, but is there a big block of solid stuff that you're melting inside? No?
You've, if I may borrow that can.
Yeah, go for it. It's empty. Go for it.
Powder.
Powder.
Yeah.
Yeah.
Laser it to make it.
So how's a laser getting through the powder to melt the
focused in.
inside bit, not the outside bit and everything?
Powder rather
You get
than
a top
solid,
layer
but yes,
where
but
it does that,
but
then you
it's-
push another layer of powder over it.
Ah,
Yeah.
right, okay,
Ah.
you missed that
One
point
foot
there.
from the melt.
Okay, good point.
Excuse me, what was that last point?
So imagine you're printing a
Yeah, got that
thing
bit.
inside here. You start with a thin layer of powder.
Yeah.
Laser melts whatever shape it needs to melt. Machine pushes more powder over it. You
Ah,
melt
right,
the
okay.
next layer.
Mm.
You push more powder over it. You melt the next layer.
Yeah, I had the impression it was sort of being suspended inside the powder. I couldn't work out how that was working because you'd think it was fused together, it would drop.
In the end, it is suspended, funnily enough. So because you can start with a thick layer of powder and just melt the top 1 micron thick.
Yeah.
And because of the way the powder is, nylon powder is very dense. The object actually stays suspended, so you can pull it out, use a wire brush, and scrape all the dust off it. I've got a video showing us that
Okay.
in a minute. It's super cool. And FDM, which is what everyone uses, melt a piece of plastic, melt a string of plastic, draw lines with it. So, pop quiz time. Sorry guys, I'm a teacher. And because I'm a teacher, I've actually got prezzies. So
Do we need to play the prize
I
right?
was going to say, as a teacher, I approve.
fully 3D printed. All right, question 1. How old do you think FDM 3D printing tech is? Give me a year.
1990s.
2009.
Nope.
1960s.
2006.
Nope.
1985.
2010s.
Good year.
Very close.
What did they say?
84.
Higher or lower?
1986. Oh, there we go.
1989, actually. So, all yours.
That's when he was born.
1989.
Probably was.
What defined that butt?
What defined 1989? Why
Oh.
was it called FDM in 1989?
I'll show
'Cause
you
we've
because
been
there is an actual
doing
patent.
stuff forever. Yeah.
Oh wow.
Ah, yeah, I've heard Stratus.
So Scott Crump, the founder of Stratsys, that's the patent.
Yeah.
And you'll recognize the apparatus. Nothing's changed since then.
Wow.
So it's that way the paint and finish.
And we no longer call them 3D plotters, we call them 3D printers.
Mm.
So FDM turned up in
Because a
89.
plotter did do that, didn't it?
Correct. So 1980s.
So advanced, yet it's so back in time.
I'm also going to point out that that patent didn't expire till 2009, which is why they didn't printers didn't turn up. So I was just saying, while I was working on this presentation, I went to look at the history of 3D printing and realized I'd been in 3D printing, oh God, spelling error, that's okay. I've been in 3D printing from 1 year after the patents expired. So yes, that made me feel old. But
So,
okay.
so was there an explosion of 3D printers
Absolute
after?
explosion.
Yeah, okay.
Oh wow.
Yeah.
So there's people waiting for that to expire just to go jump on it. So it's
Yeah.
been held back all that time.
Yeah.
Yeah, right.
You
That's
can blame
crazy.
Stratus for it.
Yeah.
Wow.
Well, they
Okay.
invented it.
Don't do much with it.
Another one. How old do you think SLS is? This is the powder bed laser sintering. We know that FDM was 1989.
Let's go 8 years.
Forward or back?
That's the trick, isn't it? 8 years back from now. Older.
It was 60.
Which is back from then or now?
No,
now.
Now.
Nope.
Pretty.
82?
96. Yeah, it was pretty early.
We've got an 82. That's getting close.
1980.
Not too far away.
81.
1985. 85.
Well, it's got to be more.
85. Did someone else say 85? Someone said 85 in the back.
No, 96.
That's a
86,
TV show, isn't
actually.
it?
Oh, 86.
86. Closest.
99.
Oh,
okay.
Yeah. So
It was
SLS.
earlier than the
It was.
right.
Descartes.
So
He was a philosopher, wasn't he?
was it?
Descartes.
Oh, okay.
Sorry.
Peanut Crew's in the front row today.
Has he had his pills today?
So funnily enough,
What time is it?
His teeth are back.
funnily enough, that hasn't changed much either. It still looks pretty much the same, only instead of going horizontal, it's a vertical system. That's about it. Which brings us to, if we were listening, how old do you think SLA is? This is the UV light printing. There's one sitting there.
Following the trend,
20.
1986.
That was 1986 earlier.
1981.
20.
Too far away.
1983.
88. 84.
84.
Great.
Actually, did someone say 84?
Well, the other one was 84.
Well,
He said 1884.
hey!
That was a miracle. Thank you.
Actually, guys, the original patent for this was in 1980.
Oh, wow.
However, that resulted in that, which is not much of a 3D print. It was more proof that, yes, you could burn layers together.
Yeah.
The
Oh wow.
each of those layers is 2 millimeters thick. That is positively
2 millimeters.
gigantic. Yeah.
Just slapped it.
Just clear resin.
Okay.
1984 was when Chuck Howell patented what we recognize today as SLA. And once again, not much has changed. The reason being, all these patents expired fairly recently. So any changes that have only happened in the last 15 years or so. Okay. Since you just said after 2009, was there an explosion? Welcome to the first major Kickstarter for 3D printing. Is the sound good carry through?
Got that
That's the
sound.
sound.
The
good.
sound. Just
Probably in here. Might be on YouTube.
That's all right.
Running commentary.
Yeah, you're welcome to add commentary. Yeah.
All right. So you can see that was what the Formlabs one was about. You'll recognize the same shape here, just slightly different. They advertised clear resin, which we know now is painful to work with. It's much easier to work with boring grey resin. And actually nothing much has changed in what they talk about. There's the So you basically get a UV laser that gets reflected around.
Like a laser printer.
Yep, but in 3D.
Yeah.
We got more videos with sound coming up.
Yes.
I'll plug in.
Thank you. And it punches through and hardens some resin.
Okay. So, Praj, where that's hardening the resin, it's not necessarily the surface of the resin bed, is it? The surface of
No,
your
so-
resin fluid, is it?
Glad you asked. I've got show and tell.
Yeah.
So that's your resin bed. That is what connects up to the
Looks like
vat
a
here.
mirror.
That slowly pulls it.
So that rises out of the resin.
Okay, all right,
So-
cool.
The resin sits in there.
Yes.
It, notice it's got that lovely clear thing down the bottom.
Yes.
It's called a FEP. The screen down the bottom has the mask and the UV light coming through.
So that's just an LCD screen or something?
That's just an LCD
Yeah.
screen. The light source is UV.
Yeah.
That's about it. This basically drops in. Once the first layer hardens, lifts up, goes back in. This time, just that 0.1 micron higher. And the next layer hardens, pulls out, goes back in, another 0.1 micron higher than previously.
That's super cool.
And the plastic down the bottom goes twang, twang with every peel because you're basically suctioning the thing off.
So it's working effectively the same sort of thing as an FDM. It's just working
Yep.
with a different
Yeah.
type of
Ha-
in reverse sort of.
What period between layers? Is it twing,
Um,
twing, twing?
It's up to you. It depends on how hard you want your model. The exposure time can be calibrated for that.
You start
Because
building-
1 micron, so that's 1,000 layers for 1 millimetre.
Yep.
So that could take some time if you're a few seconds or.
But I do between 7 seconds to 15 seconds per layer, depending on how hard I want the setup. And remember that unlike FDM, we are not printing one line after another. We're printing an entire layer at a time. So it's actually remarkably fast.
So
compared to-
are you building up from the top down or from the bottom up?
The bottom's attached here,
Yeah,
and
right,
that's what
okay.
comes up. So
Yeah, okay. So it's
I'll-
inverted.
yeah, I'll show you a GIF of the thing actually doing that.
Okay, thanks.
Now, the problem with the Formlabs printer was, if I remember my numbers right, it was the better part of $3,600 US. I remember looking at that Kickstarter going, God, I want one of them. Couldn't afford one. It's just, that's too expensive. But that was when it came to the desktop world.
Wow.
That is basically how the printer works.
Not that quick though.
Not that quick. That's a time lapse.
Are there health issues with resin?
We'll talk about that in a
Okay,
minute.
so-
I've actually got a friend and colleague stepping in for that because the kind of 3D printing I do with resin is mostly artistic. I build models that sit on a shelf and I paint them. I'm a molecular biologist. I've learned.
Yes. Has this got audio in it?
I
No,
think you
oh
can
no,
have
this is
audio.
just a GIF.
Yeah.
So should be good. I learned fine motor control skills to inject DNA into cells. Don't do that anymore. So now I paint miniatures. But my colleague Rob, former colleague, will come in. He builds functional things out of resin, and I think that's super cool because resin's incredible when you do functional stuff with it. Now, if you're wondering what on earth that sort of stuff that you could see there coming off model is, if you suspend something, where's my, oh no, that's all good. Wait, it's
Sharing for your own.
No.
Oh, you sure? He's got the book. Yeah. Oh,
since we're in Tasmania, thought I'd print a thylacine skull.
Cool.
Oh, love it.
Yeah. So this is not going to attach itself to that.
No.
So you have supports that are built onto the plate and the whole structure hangs off it. This is a failed print. You can see the back of the skull looks really weird. But there's a reason I brought it along. I'll talk about it in a minute. But that is the support system that the whole skull hangs off when you print. So that's my current SLA printer, not this. This was the printer I started with. This one I picked up in 2022 for the grand sum of 489 Australian dollars.
Wow.
So 2012, 3,600 US. 2022, 489 Australian.
Wow.
You can pick up this for about 300 Australian when it goes on sale at the moment. And it's actually a slightly better version of this that you pick up. Because this one's, they call it the Mars Pro now.
Cool.
This one is a lot fancier, so I'll look at the difference when I... So it's got the... To start with, see the two locking wings on there? Much more stable than this wobbly thing up here. That's a ball joint.
Ah, yeah.
It's got a camera. I can monitor I can monitor my print, and when things go sideways, I can actually turn it off wirelessly. It's got Wi-Fi as well.
Cool.
It's got a light,
Nice.
which causes problems because they cheaped out and put in a full spectrum white LED in there.
Oh no.
UV cures resin. So you leave the light on for too long and you get a nice little skin of cured resin on top. Gotta be careful. This one runs off a single rail, twin rails,
Yeah.
a lot more stable.
Wow.
It's even got a little vent in the back to attach an exhaust fan to and suck all the fumes out because resin's nasty. Rob will talk more about it, but resin is nasty. Now, one other thing is an absolute blessing. I want you to take a look at the state of that lid.
Oh, God, yeah.
That is me picking up the lid every time I printed with gloves that had resin on them. So that's now cured. I've hit it with UV, so it's all hardened. But every time you take a print off, you've got to take the lid off, find some place to put it, and then deal with the mess. The satin just tilts the lid back. Personally, that's my favorite improvement. And then, this is the coolest thing. Resin printing is chemistry. Resins work best at a certain temperature. So I don't have the setup here, but what I used to do with this was a beer brewer's vat heater, you know, the belt?
Yep.
Strap the belt around there, connect up one of those Inkbird thermocouples in there. That's what that blue tack was for. Put the lid on, and it'd just turn on till the temperature got to 25 degrees.
Wow.
And for the air temperature to get to 25, that'd be at 28, which is just perfect for printing. That vat is heated on that printer there. And what's even better is it actually has a tilt function. So remember how I said it goes twang when you pull it up? It doesn't, it peels. Which means the FEP down the bottom survives so much better, because I'll leave it to Rob actually. He's got a story about changing FEPs, so I'll leave that to him. Now you may have noticed, if I go back, that lovely silvery shred around the printer.
Oh, yeah.
Anyone here who's printing open frame printers or resin, if you already aren't doing this, grow tents, they cost about $60 on Amazon. Life is good. It holds temperature because it's got that lovely silvery layer inside. Keeps the smells in. Don't have to worry about anything. And they even come with vents, so you can vent and pump things out if you want. $60 collapsible frame, move it wherever you want. Beautiful thing. So, once we move past the cool bits, here's a problem with resin. I left that sitting for a week in the vat. It separates. So you actually get in there, give it a nice stir. If it's this printer, my new fancy one does the mixing, so I don't have to worry about it. This is just a demo. But resin separates in bottles. If you don't give it a proper shake, you're going to end up with the compounds all over the place, which means your product's not going to be what you want it to be. And then there's the mess of you've got to wash it after it comes out. Then you've got to cure it. And you've got to have a silicone mat because anything else will just absorb the resin.
Oh, no.
Resin is something that can give you super detailed prints, but it's super messy. Super, super messy. That, by the way, is not yet assembled version of Sauron the Dark Lord.
I was going to say Sauron's helmet.
Yeah. Reaching out, one ring glowing on the finger, mace in the other hand. Cool. Gonna have to assemble it. And that is what curing resin looks like. It's basically going back to the disc. Now, I got that because I got it on sale. You don't need to get the fancy thing. You can literally get a Bunnings bucket, put a strip of UV LEDs inside, turn it on, put the thing inside, put the lid on, you're done. The wash station doesn't need to be that fancy thing. Rob will talk to you about what he did. He doesn't have the fancy wash and cure station. It works just as well. Fair warning, I only work with pretty prints that I paint. So I use water washable resin. My life is a lot easier than Rob's. He is a miniature railway builder. He leaves things outside, exposed to the elements. So he's got to use completely different techniques to work with it. So what resin boils down to is resin's messy, resin's toxic, I kid you not, actual carcinogenic toxin. Resin's a pain to clean up. It's sticky, it leaves a mess behind.
Once it's solid, it's not toxic, is it?
It isn't, but you've got to be very careful about making sure that it's properly cured. So in the early days of resin printing, I walked away with a print that I thought was perfectly cured, left it sitting on a countertop, come back to it a week later. Liquefies.
Wow.
But we'll leave that to later. Quick thing at SLS printing. Once again, you're going to see another familiar name here.
Space launch system. Just went to the moon.
Design and manufacturing workflows are closer together than ever. But our ideas still often exceed what we can physically realize. A new wave of independent manufacturing starts now with the Fuse 1. An affordable, compact SLS 3D printer with an intuitive workflow. Selective laser sintering, or SLS 3D printing, is relied on for printing strong, functional nylon parts. In the past, SLS has been too expensive and difficult to use for many businesses. The Fuse 1 allows you to fabricate production-ready parts and high-performance prototypes. Control your entire process, from iterating on your first concept design to manufacturing finished products. The process starts in Preform, our print preparation software. Preform's part packing algorithms can automatically arrange many models in a build. During setup and printing, the Touch UI walks you through every step. Monitor your print from the touchscreen or from your computer via the integrated live camera. Once your print is complete, transfer the build chamber to the Fuse Sift. This safe, efficient powder recovery station completes the workflow. Fuse Sift will automatically dispense and mix used and new powder after you set the ratio. Reduce waste by recycling powder at a 30% material refresh rate. This means you can print with up to 70% recycled powder. After you've transferred a completed build to Fuse Sift, swap out the entire build chamber from the Fuse 1 for non-stop printing. SLS 3D printing fuses nylon powder layer by layer. The unused powder supports the parts during printing, so you can create complex, interconnecting designs with no need for support structures. Nylon parts balance strength, flexibility, and detail, so prints are ready for rigorous functional testing, or to ship ready-to-use products to customers. It's time to rethink product development and take control of your own manufacturing. The Fuse 1, Production SLS, finally within reach.
You'll notice that at no point did they mention a cost.
If you're going to ask, you can't afford it.
I'll give you a clue. The nylon powder costs $100 a kilo. Affordable SLS 3D printing is, if you want the entire package, the printer, the sifter, the reclaimer, about 140,000 US. That is cheap by what they used to be. They used to cost more.
Can we put that on the committee for next year, please?
He did say, businesses.
We've got to collect those cans.
So, notice how they did the chainmail. The Fuse came out in 2021, and at that point, it was only Fuse that could actually do something like that. You needed SLS to print in place. I printed this last week, FDM.
Oh, wow.
Yeah.
Print in place.
Wow.
There's another one. Just right.
That's incredible. And this stuff, to buy it, proper chainmail is very expensive. I do LARPing, so. Jeez.
But so it
feels right.
Yeah. It's amazing how quick 3D printing is actually moving along. That is a standard FDM print. Just printers have gotten that good. This is on a printer that was released October last year.
Looks like a handkerchief. In the race industry, print turbine wheels for turbos using steel powder.
Yep. I'm
Intake
actually
manifolds. That's off the shelf.
Is that a fancy filament printer? Or
that
an
is
ordinary
a
filament?
$1,274 printer you can pick up tomorrow from Officeworks. I've checked, the local one has 4 in stock.
How much do they pay you?
So pretty ordinary, great. What's the commission rate?
I wish there was one. So, there's good news on this front though. Once again, Kickstarter. Last year, 3,699.
So that's $5,000 Australian.
Unfortunately, the Kickstarter went live in June. In July, so Formlabs bought out Micronics. They're now talking about a lot of amazing things. They're talking about bringing it to desktop using Micronics' technology, but we'll have to wait and see. Formlabs has a history of bringing big things down to scale.
Are they honouring the Kickstarter? You know?
Sorry?
Are they honouring the Kickstarter?
They're not.
Refunded
Refunded.
and received a credit for
It caused quite an uproar. So,
squashing the competition, it sounds like.
so, quick comparison of technologies. You print SLA, you get incredible detail. Feel free to pass that along. That, by the way, guys, is a skull that used to sit on either in Rob, the friend who's going to come on, in his drawer or on my desk, because we used to use that at UQ to teach evolution, an actual thylacine skull. One of the researchers went and CT scanned it, printed it.
Wow.
So SLA gives you incredible detail. It gives you really fine detail. If anyone wants to, here's a fun little project I did to fool a whole heap of second year evolution students. I printed the bones of,
What's the scale?
that is a quarter life size. Printed the bones of a horse, a lizard, a bearded dragon's skull, and a set of bat wings, put them all together, put it in with their archaeological fossils, put a little official nameplate there calling it Ignis Fatus. It literally means foolish flame. And you'd be surprised at the number of second years who very carefully wrote the name down and moved along. As, oh yes, here's a specimen that we've looked up. Feel free to check them out. That's really delicate bone.
Okay.
But that's printed.
So I feel like that was echoes of what they thought happened with the platypus. Yeah, they thought it was a fake. Oh my gosh! Wow. What's it?
You call it Fatus.
Ignis
Okay.
Fatus, foolish flame.
Ignis Fatus.
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 Wowzers. And the attention to detail on that scale too is absolutely magnificent.
So
AI now.
I'm glad you said that because Rob is going to talk about that.
That is amazing.
It just gets scarier and scarier.
By the way, guys, at the end of today's talk, the Tassie Devil skull that's floating around, well, crack it open because that is from a CT scan. The internal structure of the skull is the internal structure of the skull.
Wow.
So we 3D printed a wombat skull at one point at work and printed it out, looked at the teeth and went, did the printer fail? No, it turns out the wombat had poor teeth. And then we realized that this is a CT scan of a living wombat that's running around in Lone Pine at this point. So obviously word got sent back saying, your wombat's got dental problems.
And they fixed it, right?
Yeah.
Yeah.
So you can diagnose issues by CT scanning a wombat and printing out its skull and looking at it.
Exactly. Look at the CT, you wouldn't need to print.
Oh, but the CT wouldn't give you the kind of information for the surface because the slices happened this way.
Unless you can put all that together in your mind.
If the slices had happened this way, you could have. But it was vertical
That's
slicing.
gone that
So
way.
you
has
assemble
gone
that
this
and
way.
suddenly you see the back teeth.
Now that's a good point. Do you need to use the slicer if you do a CT scan?
You still do, because you have to assemble the slices to make the STL and then re-slice it to print
The other
it.
way around.
Yeah.
Facetious.
If you do it to the right,
These stack together and you break them.
That's exactly how it came off the print bed. I did nothing to it. It's straight off the print bed.
presumably if you print 3D prints like that, you can actually feel the forces that are going on within the skull as well. You need to. You get more than you get for a CT scan.
No, this is the same. This is the same printer we've got in the shed.
That's a Bamboo Labs P2S.
Well, we've got a Creality.
Creality will do that too.
Ender 3 or something.
Enders will.
Ender 3
Enders
version
can't
3.
do that.
That's the one I've got.
Enders will struggle with that, but
Yeah.
Creality is sure. The newer Creality is sure.
Yeah.
It's Sherlock Grey.
You've been along there, haven't you?
You want the
I
mic?
have not
That's
seen
amazing.
He's seeing if it's genuine. It is genuine plastic.
Get that loop out.
Steady on.
running around.
That's a question.
All right, guys. To bring us back to what we can actually do with 3D printing at the moment. Anyone here working in the medical field? Nope. That's a full hip replacement in titanium 3D printed.
Wow.
Printed in titanium.
In titanium. SLS. You get titanium powder, you fuse it with a laser. And you can build it literally as a replica for whatever hip you're replacing.
That's amazing.
So it fits perfectly.
And
What Tim got.
Is the printed surface such that you don't have to do anything to it?
Yes, there is. When I looked this up, I ended up running into 4 papers published in the last year that were talking about making the titanium porous to let
The
nerves
bone
and blood
grow.
vessels go through it. Yeah.
That's why a chunk of titanium
Just to keep
follows. You've got no L4.
That's
One's in
amazing.
metal, so it does.
That's a replacement sternum.
Kim's lunchbox.
Sternum with ribs printed in titanium.
That's my leftovers, Jim.
And the bulbous bits.
They attach to the broken bits of the ribs. So it's
So
literally
they've used a bone saw, taken everything out, and put that in replace. Crikey.
You can print soft materials, so prosthetics, or especially for soldiers who've lost body parts, maxillofacial replacements. You can
Amazing.
rebuild from their facial scans.
Could they pick their own nose? Sorry.
And then I bumped into this paper, which is not this is what we think we can do in the future. It's a fascinating read. I'll put the link up on Discord. 3D printing organs is, from my understanding, about a decade away. Wow. As in, we can do that in the lab now. We can build lattices that build an organ around it. But just getting it to a position where you can actually implant said organs into
Not the
people.
organ you need.
That's amazing.
What's the material that they use? Like, it's obviously an organic material.
It's usually some sort of organic biodegradable plastic.
Okay.
Sometimes cellulose is used. My favorite one is where they use sugar. They've spun heart structures out of sugar, 3D printed in sugar. So the entire thing just gets eaten
make your
by
sugar
the
look
heart
better.
muscles.
Yes.
The heart muscles eat it.
Okay, yeah, they create a lattice, put your cells in it, and it rebuilds a heart.
Yeah.
Oh wow.
This is not stem cell stuff. This is
No. Oh, if you want stem cell stuff, there's a whole other thing happening out there with actually printing with cells, which is a completely different story.
Okay.
You actually
That's
layer
amazing.
cells.
That is amazing.
And that's just medicine.
Trust it.
Printing cells on Artemis 2
They're doing some incredible things up there.
as a trial.
as well as going around the moon.
We all know that CSIRO invented Wi-Fi.
Yeah.
Yeah.
CSIRO also made the first 3D printed jet engine back in 2015.
Wow.
That was on display at the Avalon Air Show.
Actually, so Festival of Bright Ideas, probably over 10 years ago, they had an impeller. And I picked it up and I didn't realise it was metal. And I went, oh, this is a metal. And they said, yeah, it's printed in metal. And I looked at him and went, you've got to be kidding me.
Fully unlocked.
Given how
building
long
rockets
jet
now
engines
with
got to get
3D printing.
tolerate temperature-wise, that's impressive.
So for components like that, when you print them, the finish is as good as a machine finish.
The finish is
So-
better than a machine finish because
So-
you can print
so
to
it-
nanometer level.
So they'd be much cheaper to produce rather than
Way
actually
cheaper.
having to
No machining.
no machining, but you don't have to make the casting. You have to have the impurities in the
And it's
casting.
got galleries for cooling.
And it'll be
Oh,
lighter
I'm
too.
so glad you brought that up.
Yeah.
Anyone here who's a mechanical engineer, thermal, you'll love this one. Heat exchanger with gyroids inside. You cannot machine that.
No.
That's pretty good.
Gee whiz. Even jet engines have actually got to put things into it to
So
do
you've
galleries.
literally got
Yeah.
2 chambers,
Yeah,
fingers interlocked. 3D printing.
So I can cool my beer wort with that.
Yep. just need to get yourself a titanium SLS printer.
Says the Cisco guy. That's all.
That's one way to cool the service.
Sorry,
Is the longevity equal to the machine components?
identical. If it's laser sintered, it's identical.
Yeah.
If it's filament deposition, we're going to talk about that afterwards. It's not.
Okay.
Laser sintered, insofar as we know, they seem to match.
Wow. It's pretty incredible stuff.
The other cool thing is 3D printing ceramics.
Oh, wow.
So now you're talking about materials that can tolerate excess of 3,000 degrees.
Absolutely.
So you put that into machine equipment that needs that kind of thermal tolerance. You 3D print it.
Yeah.
So Marcel, Ruby can try this out.
Wow.
Marcel's wife is a ceramics artist.
Right.
So, sorry, I'm going to ask a question. So, how the heck they, 3,000 degrees Celsius, how the heck they print something that's
Lasers hotter.
You print with clay. You hit it with laser.
And then you fire.
Ah, yeah, okay. Yeah.
You fire each layer.
So it's literally you're basically printing with soft clay, and then you basically hardening it.
You're firing it in a way that the clay isn't fully hardened up top, because the next layer should adhere.
Adhere to it. Yeah.
Yeah. And then there's material science. I had a good chuckle at the last talk that I was listening on YouTube, and I went, yeah, I'm going to have to talk about this. So, Justin, for the helmet, you can 3D print lattices. Anyone here who's been in the armed forces? I can tell you that the foam in the helmets is horrendous, sweaty. It absorbs all your sweat, and then it sits heavier and heavier and heavier on there. You can 3D print a lattice that has actually been shown to be up to 10 times more efficient at reducing impact, while being hugely lighter. There's barely any material there.
Cooling.
And more breathable as well.
Breathable as well.
Does it stop a bullet or shrapnel?
10 times better.
The outside does.
No, the foam stops it 10 times better than this stops it 10 times better than standard foam.
Okay.
Helps disperse the energy, doesn't it?
And that can be printed in Kevlar or some other material.
TPU.
Yeah. Okay.
That's bog standard TPU.
Wow.
Okay.
But it's just the shape that helps deflect it.
It's a geometry.
Wow.
The cool thing though is if you have an idea like this, you can run away with it and completely 3D printed shoe. It is designed for your foot. They scan your foot. If you happen to have
Look at the price.
1,500
euro.
There's only 3 left.
Based on
that was yesterday. They might be gone by now.
Based on Yetis or Bigfoots.
Yep.
So is that
However,
per shoe?
Sorry.
Is that per shoe?
Oh, I mean, it does say Crooked 1.
Three left.
Three left.
Someone's got one left. You can have one short.
Oh, they're the lefts. They've got to buy the right separately.
Left feet only.
But they're coming 3 to 4 weeks.
Peanut gallery down the back.
I've got something better. For anyone who's got a 3D printer and doesn't have the money to buy one of those because you've spent your money on the 3D printer, that's available for Mackay-Wood for free. I kid you not. Takes my body weight, works as a really good summer sandal.
Wow.
TPU.
Again. Sounds like a Michael Jordan type of thing, doesn't
Prints and TPU. So it's actually dead cheap because a roll of TPU is $53. That's about a kilo. These weigh 83 grams each. So
you just print another pair when you wear it out. And how hard wearing are they? Is TPU? Like
that's TPU.
You want to go to the camera so people on YouTube can see?
It's what Ron uses TPU a lot, I think.
TPU is great.
Very flexible.
So I'd basically go.
Wowzers.
But how hard wearing is that
Very, very
against a
hard.
hard surface?
Very hard wearing. It doesn't come off easy. So TPU is ridiculously strong.
TPU. I would definitely
That
buy
could be
some of
the
that.
self-fixing car crash situation. Crash the car and have it spring back.
Just bounce off.
Let's try and add that to the 3DS budget.
If you hit a wombat, you can print a new one.
Yeah, he's a 3D print the engine.
Is the wombat actually going to get injured? Is a question. They're both like
Probably the car.
blocks of steel.
The car will need repair.
Whenever buses get in the crash, we'll just free to print another one in a TPU.
So, and then, if any of you ever go to Cronulla, go check that house out. That was 3D printed 2 years ago.
But full size.
Wow.
Full house,
Wow.
3D printed. You can see the seams.
Mhm.
Kiri and I were looking at this going, yeah, I would not want to be dusting that.
Can you imagine going to the council trying to get that approved? Yeah, I'm going to 3D print my house.
There's
I wouldn't even know what you're
Praj.
talking about.
You can point at this house and say they did it.
Yeah.
How do you think
ScoMo's
Joey
house.
I don't.
Resolution sucks.
How does it go in the?
Exactly.
I assume they use material that's UV stable and everything like
It's
that.
concrete.
Oh,
it's
okay.
freezing.
Oh, right. Okay.
That's actual concrete.
So I was going to ask about a fire rating
They-
for in the bush. But
It's concrete.
They did
Yeah.
put on what's the
Grand design.
Grand Designs? Yeah, they did one on that about 5 years ago.
Yeah, Kevin McLeod.
Typical Sydney. Everybody's got red tiles.
This guy.
Not this house.
We'll have to find the
So-
video.
The resolution on that is, yeah, that's what, 2 centimeters. So we go from that to we can do that.
Nano.
Really print formula.
Micrometers.
Yeah, that's 100 micrometers.
The tyres are flat.
Wow.
Yeah. So presumably that's under a scanning microscope, I'm guessing.
So the reason I'm showing you guys this is the jet equipment materials that you print, the structures and the apparatus you print. You can actually shape them at a nanometer scale to give you the highest efficiency, break up the wind coming, break up the, what's the term for it?
Turbulence.
Yeah.
CD.
Yeah.
So you can make the.
I'm
little-
just happy, guys, that I can actually print and paint that at home.
Oh wow.
Oh, jeez.
So that's come off the Saturn 6. You can see a few
She's got
layers there. Oh, I'm glad I never officially got COVID.
3D
That's
prints
what I turned into.
3D prints average. I'm more impressed with the painting, to be honest.
Yeah.
That's fantastic.
Thanks.
So, Praj, how long did that take? How high is that in
About that
scale? And how long did it take to print?
The entire thing, about 22 hours.
Okay.
And it's mostly hollow.
How much support structure was on that?
Quite a bit.
Yes.
Look at the detail.
Damn right.
So,
The most interesting thing.
Do you have nightmares?
Oh, wow.
I've got some weird things printed out at home. So that is all the stuff that fancy companies out there can do. That's what my printer at home can do with 3D printing. And you'll notice that there's not a support in sight.
45-degree angle.
By the way, if you're wondering what that is, this little thing back here is what's called a poop chute for that printer. It pushes any waste filament out through the back, but the company in a cost-saving measure, didn't provide a way to catch something coming out of that poop chute. It just pushes it straight out onto the table. So this opening goes in behind that, and it catches it, wraps it around the printer, brings it forward so I can pick up the stuff.
I love it.
Praj, I noticed there was a bamboo lab
Yes,
thing, name blank. What model bamboo was that one?
P2S. So very short history of 3D printing, guys, because I'll be switching to Rob in a minute.
Wrap.
That was the first FDA machine that came out after the patents lapsed. And then Joseph Prusa went and built the Prusa Mendel, which Rob is going to show you because he's got an original Prusa Mendel.
Wow.
And then he built the i3, which became history. Now, in terms of my personal history, my history with 3D printing started there. Once again, a Kickstarter. Yep, it's a 3D printing pen. I've still got it at home. I just didn't bring it in. I was running out of space in the bag. But you can literally print plastic in air. Fun fact, it's still available.
Is that using the same filament as you
Same
put in
filament.
the 3D printer?
Exact same filament.
JCAD got their own version of it as
Yeah.
well.
Wow.
Then I backed another Kickstarter for a little cube. Great idea, terribly executed because the beds were not level.
Oh, no.
Like a lot of Kickstarters.
Then I got FlashForge Creator Pro in 2016. In between that, I was playing around in the Brisbane hackerspace with a whole heap of Mendels. This was my workhorse for many years. It has 2 extruders. It can print 2 different materials. Here's a failed print from that. You can see the support structure is white PLA. The actual material is wood. It's wood filament. So I can polish that up. I can stain it. I can do whatever I want.
That's amazing.
Wood.
Yeah.
Cellulose.
And as a challenge at the end of the talk, that is a 3D printed puzzle tube. You're going to have to figure out how to unlock that. Printed on the same Creator Pro.
I shouldn't have a go to actually got one at home. So.
Then, so this is what I talked about the last time I was here and talked about 3D printing. We had this absolute beauty of a Kickstarter where Anker decided that they were going to build the fastest 3D printer in an open frame at that time and sell it for $399 US. So of course I got myself one. And I wondered how they were going to keep up that business model. Well, it failed. The company failed about 1.5 years after. Eufy bought out that brand. They make a cheaper version of that printer now. And my Anker Make died. So I brought its head along so we can take it apart and see what it looks like on the inside.
It sounds like macabre. You brought the head along.
Head on a stick.
Beauty of a printer. Worked spectacularly till it failed. And unfortunately, I can't get the replacement part because it's a custom part. And it's not something I can fabricate. So, fun story, Justin. When we started talking about, I sent you those pictures of prints saying I'm starting to print. This thing, I turned it on, typed a few commands in, and it went thermal runaway. Okay, what do I do? I've been talking to Kiri about this for about, I think, a year before that, going, I'm not sure how long this printer is going to last, and I'm not sure if I can get a replacement. Well, she was okay with me going and buying the Bamboo Labs P2S. Now, for the first time, I've got a printer that actively swaps filaments, prints in different colors, embeds things, does super cool stuff. And as someone who started working with Mendels, where every nut and bolt had to be tightened to make sure your first layer is perfectly flat, we'll talk about that more. This thing, I plugged in, I turned on, it leveled itself, 128 points of leveling. It then ran a sound check to see how the motors sounded in the space, retuned its motors so it didn't sound too bad. Then ran a vibration check, because when it does squiggly prints, it vibrates super fast. Now has a compensation algorithm that it's built for itself because it's sitting on a slightly wobbly table. And I'm going, I don't feel like I'm 3D printing anymore. I'm pushing a button and it works.
And I assume all those filament rolls are in a heated
They're in a heated thing.
enclosure.
The things up here are 3D printed. They're filled with silica gel. I've got a hygrometer there.
Just vanilla.
So, time for a very quick demo. I printed this, I didn't bring it, it was too big. I'm going to use it with my students. It's a giant Easter bunny. But
should be a bilby.
Should have been a bilby. I agree. Couldn't find one.
Very shiny chocolate.
So, this brings me to, I was looking at the 3D printing channel on Discord. Lisa was asking for a modified print that would actually fit the battery that she's got. So I went, okay, let's try this. I'll wait for the bunny's ears to finish.
What's the time duration of this? Right.
That was a 17-hour print. Because that is a free spiral, you can actually pull it open. So let's go to demo mode. Demo mode being... I downloaded the file that Lisa pointed out, which was, hang on a second, there we go, 3D printing. Let's go back. That was the one. I pulled it down, and then she'd said that the battery was a 6066, 60 millimeters by 66. So pick it up. That's what's the thing. Now, guys, fiddling with an STL and trying to reshape it is painful. It's easier to do it from scratch. When I showed what I was doing to Rob, he went, "Oh, I'll spin this one up in Tinkercad." So he'll talk to you about that in a minute. But if your files have a .f3d extension, how many of you here are connected to a university in one way, shape, or form? Yeah, you have a .edu.au license email. You can get the entire Autodesk suite for free. If you have a child who is at school or a grandchild who's at school who will not 3D print, you can ask if you can borrow their email ID to get Autodesk for free.
Yeah, okay.
FreeCAD is great. Tinkercad is super cool, especially if you're starting out. But Autodesk is spectacular. Now, if I fire up the model in Autodesk, you're going to notice a major problem here. A major problem being, if I measure the size of this unit from there to there, it tells me it's 616 millimeters. The person hasn't scaled it properly. Well, we'll fix that in a minute. That's meant to be...
That'll fit a fair few little...
Yeah. It's meant to be 61.6.
Might need a lifting logo.
However, let's imagine that's 61.6 mil. It's only off by a factor of 10. That's easy to fix. That'll fit one side of your battery, which is 60 millimeters. So if we go the other way and look at the depth there, that happens to be only 351, so 35.1 mil. We need that to get up to 66. So what I'm going to do, very simply, now this is the cool thing with, I select the face, I right-click it, and I'm going to move the face. I'm going to grab the arrow that actually points in that plane, pull it out, and tell it, because we're going from 351 to 660, I'd like it to go up by 315 mil. Give or take a millimeter. So suddenly I've got a very big chin on the thing. Here's another cool trick. Because that's a recess, I can grab that, tell it to extrude. Extrude literally means take a 2D shape, pull it up to be 3D. But it also means take a 2D shape, punch it in to be 3D.
Okay.
So I can go that, grab that arrow, and tell it to go in -315. I've got my slot. Then I'm going to grab that, ask it to move. We're not. It's just a flat face. It's not a embedded thing. I'm going to grab that arrow again, so I get that, and then I go -315. We're done. Lisa, this is why I said it. Don't need to worry about it. That's how quick it was to modify it.
You made that look too easy.
So once you've got this, then all you do is you go File, go to 3D Print, not to export. Sounds logical to say export. Nope. 3D Print.
You've got to divide it by 10, don't you?
I'll show you that in a second. Grab the object, say OK. I'm going to pop it in the same folder as the other one, which is where did I put it now? Oh, 3D printing. There we go. Look at Reast, live demo, and I'm going to call it live demo print. There's a reason I'm calling it live demo print. Okay, that's done. We can close Fusion. Now, that's about as easy. Keep poking around with it. If something breaks, Command Z, Control Z. It'll fix the issue for you. Now, once you've got that, I'm going to fire up my slicer. By the way, guys, I've got Tailscale installed at home, and give it a second. It will link through. There's my printer in Brisbane. Right. So I'm going to pop into the prepare mode where I've set it up.
With its poo shoot.
Yep.
Thanks, Greg.
Poo somewhere, Greg.
Yeah.
3D printed, custom made poo shoot.
Poo somewhere.
As you pointed out, as soon as I drop that on the bed, that bed is 256.
Yeah, print that. Go for it. Hit go.
Houston, we have a problem.
Watch the filament go.
I love
So
the
you s-
error. It's too big, you think?
You select that, you scale it, and because it's a factor of 10, I'm not even going to bother with the 100. I'm just going to take out the decimal point and move it one step, and suddenly we're back down to size.
Okay.
Now, with this one, what I'm going to do is I'm going to tell it that I want it flat on its back, because if I flip it the other way around, this section's going to print on thin air, not what we want. We're going to set that up. Hey, look, it's got my filament set up with colors.
So are you slicing now?
I am. I'm going to show you how it works. So I'm going to tell this thing that I would like it to print in a filament called, nah, I want carbon fiber. I'll print in carbon fiber.
Oh, wow.
So I'm going to tell it to print using carbon fiber. The PLA infused with carbon fiber. This is where it gets cool. So quality, you can set your layer height. The finer your layer height, the longer it takes to print, but the cleaner your print looks.
Okay.
There's tricks to fix that, but most of these I tend to leave as they are. The only thing I would change if I were making a pretty print is the seam. A circle has to start somewhere. It usually lines up all of them, so you get this little nubby section where the seam of the print is. That's when it's aligned. I could randomize it. So for each layer, I'd get a different seam point. It just takes longer. Given that this is a functional print, that's all good. Most of this I'll leave.
Does it
inside.
add strength, having a random seam rather than a line seam?
Not really. The strength usually comes from between the layers. We'll talk about that in a second. There's strength. Now, strength is about, I'm going to show you guys some things while Rob is talking because he's coming on straight after this. Imagine a 3D print is basically a bottom layer, walls, a top layer, and something to fill the space inside. Yep. You can set different patterns for the top layer. Is it just going to draw straight lines? Is it going to do a crosshatch? Is it going to do weird geometries? That way you make sure your top layer is nice and stable if you need it to be stable. I like Hilbert curves. I'm setting up a Hilbert curve as a top layer. I'll show you what it is. Infill, Hilbert curve again. We're making it nice and tight and geometrically meshed. And if we're using big empty infill, it's going to be a 3D honeycomb. You can sit on it. It's not going to break. That is always what I'm changing. Everything else is the preset that comes for that.
And the percentage of infill?
Is my usual standard of 15.
15, yeah. Everyone seems to use 15.
Just a quick point, guys. Do not do 100% infill. It actually is not strong. You're going to start layers sliding around on each other. Doesn't work very well. Unless you've got a really, really good printer. 100% infill is not a good idea. So I'm going to put that in there. I'm going to tell it slice the plate. Slice the plate. What has it done? So inside that empty box, can you see the bottom layer? It's actually a cross hash. It's not straight lines anymore. So it's going to print that first. And then it's going to start printing layers over it.
Would that take a lot longer than straight line?
It does. The
And
walls
that-
are straight lines though.
Is that only for one layer, 1.04 millimeters, or
0.02? 0.2, sorry.
0.2?
Yeah, 0.2.
The double line.
So it prints it all the way up, finishes off the top of the wall with the same sort of print. Now, this is where the magic happens. I hit print, and I'm telling it, send it, off it goes through the cloud. Print is on.
Is that a fork of?
He's going to pull one
That's
out
all.
from his
It's
bag.
basically all.
Identical to mine.
He's going to magically transport it from there to here.
Because he didn't save the file. He don't save.
It's printing.
Oh, there you go.
Yeah.
Watch the print head. It's cooling the chamber. It's moving the plate around.
Oh,
It's
wow.
it's actually at home itself. Figure out where it is in space.
It's doing its calibration.
Does it run through a bed level as well before it starts? Or
It will do a bed level in a minute.
Yeah.
Do you have any problems with the model adhesing to the plate?
Not with that plate. We'll talk about that.
We have all sorts of issues at the shed. We're
Rob's gonna talk
using
about
masking
Put in your
tape.
colour request, Lisa? Did you put in a colour request?
You're getting black.
Carbon
Yeah.
fibre.
Carbon fibre.
Any colour unless it's black.
As long as it's black,
As long as it's black.
Jim.
Praj, 2 questions for
You're
you.
a donut.
Because this is clearly a functional print for something amateur radio. It's not one of your complex models.
Yeah.
How long would you expect this print to take? And the second part of my question is, we're watching it getting itself all warmed up and levelling and self-checking at the moment. How long before we expect to see the first layer go down?
7 minutes to the first layer. 1 hour 29 minutes to the whole print being done.
Okay. And that's because it's not necessarily complex like those models that you have. Okay. All right. Thank you.
I'm not going to make us sit and watch for 7 minutes. I'll come back to this in a minute. But you can see it's using the poop chute. It's because I was
He's
last.
very proud of his poop shoe.
It's the first printer that I've had that actually does that. So, and you can see it's pulling the carbon fiber filament through.
Mine does it down the side.
Yeah,
And
mine
this
just
one's
does
got
it.
a side entry as well.
Yeah.
Mine just does it. Mine just does it wherever it wants to. It's just.
All right. While it does its thing, I'm going to start by calling Rob because he's been waiting patiently and I've been blathering away here. Okay. While it does its thing, let's
So
call
it'll take
Rob.
about an hour and about another 3 weeks till you go back up there and can post it back down.
Yeah. Well, there you go. It's basically flicked the bits off. It's changing the filament across. I'll call Rob in the meantime.
In the old days, you had to do all this manually. That's why when I was telling you
Yeah,
last
which
week,
one is mine?
it's so much better now. You don't have to do
So what do you
any
mean
of
the
this
old
crap.
days? Some of us still do.
The old days 4 weeks ago.
Yeah, that's true too.
Hold that thought.
All right, guys. This is Rob Mackay-Wood. He used to be my boss back at UQ. He is a fellow tinkerer, fellow biologist, fellow. I don't know. He's done firsts of so many things. He hasn't gotten into radio. I haven't convinced him to do that yet.
We've got a deal for him.
We'll set
Go
a boat-
easy,
we'll-
peanuts.
We'll set it a boat thing.
But Rob's been tinkering and building things for a very long time. E-learning at Sydney Uni, he was one of the people who helped build it. He was one of the people who actually, from the stories he's told, crawled around with spaces, running cabling through to get systems to work at Sydney Uni. Then he came up to Uni of Queensland. I started to work as a part of his team pretty much a year after he started. And then I think I said to him at some point, Rob, if you retire, I'm going to quit. And he retired, and then I quit, and I'm now a school teacher. So, Rob, this is the Reast crew, and everyone, this is Rob. I'll hand over to him. You'll notice in the background that...
Testing 1, 2, 3. Good.
Yep. Beautiful.
Okay, I'm just going to share my screen. And I have to turn my FaceTime off because it's very disconcerting seeing myself. Yeah, as Praj said, got my audio coming back at me too, that's weird. Yeah, biologist and manager, retired from UQ, UCID, and from Cornell. And I'm an IT nerd like Praj. I self-taught my first computer was a 1 megabyte Mac,
Wow.
1986. And it was the top of the range, $5,000.
That's going to be worth more.
And as Praj said, I was an early adopter of the internet, and I actually used Photoshop 1.0. And I used to build networks around our building. We ran wires from the basement up to the labs on level 4 and then up to the teaching space on level 7. So we snuck them around everywhere. I'm a lover of all things sciencey. I'm a bit of a tinkerer. I love fixing broken things. And one of my other hobbies is fixing old steam engines. So, toy steam engines. I taught myself how to use a metal lathe. And some of my steam engines are over 100 years old. I'm a garden railroader, as Praj said. I've got live steam. And I also use dead rail RC. And because it's garden railway, model railway, there's lots of different skill sets that you use, like wood, metalwork, and electronics. And my little railway is called the Addledo Bush Tramway. Addledo. And now I'm a 3D printing enthusiast. And if I need it, I make it. So that's my little plug for my Addledo Bush Tramway. You'll see lots of things on there. I've also got an eBay store where I sell some of my 3D stuff. And I sell it all around the world. This is my first printer. It's a real mess.
That's the Prusa i3 S3, yes.
Yeah, it's a Prusa i3. It was a kit set. I wasn't sure whether I wanted to get into this lark of 3D printing, so I was also a single dad and didn't have a big budget. So I think that was about $80 or $90 off eBay. And on the right-hand side is my first print failure. That was supposed to be about 2 centimetres high, and it ended up being about 18, and the printer just cacked itself. So it was a real learning curve, but it was fun, and I had Praj as a mentor, which was really good. Okay, Praj, over to you.
Thanks, Rob. Look, it was fun introducing someone to the rabbit hole that is 3D printing. And before I show you whatever's happening, you can see it's put down the first layer there. The printer's put the first layer down, off it goes. Now, for 3D design, Rob will talk to you about it in more detail, but I want to introduce you to a fantastic tool called Tinkercad. Tinkercad is free. You just need to make an account. You sign in with said account. If you happen to be a teacher, you can actually run classes. I have worked with kids who have designed things. Oh, wow. And you can do some amazing things on Tinkercad. Now, just to give you a general idea of what you can do in Tinkercad and what you need to think about, got a cube up there. Now, in this cube, I'm going to pull this out of the way. I'm actually going to delete them so we can restart. That's a cube. I've literally just grabbed the cube, selected the cube. If I want to know the height, I click on that. Oop. Oh no, I'm lifting it off the print bed. No, that's not what I want to do. That is 100 millimeters across, 100 millimeters deep. And if I spin it around, it should tell me. You can tell I'm not very familiar with Tinkercad. You can actually go, yep, that's 100 millimeters high. With 3D design, the way you think about design is addition and subtraction. That is a cube, that is a solid cube, 100 by 100 by 100. I grab a solid hole. This will make sense. There's a hole, I pop it in there. Now let's say I want to make that a hollow cube that's got 10 mil thick pillars on each side. I literally just go 90.
Make them 5 mil, won't it?
And I've basically got something that's 5 mil on each side. Now, to get it off the floor, I can grab that arrow and pull it up 5 mil. Now, given I said I'm going to do something that's 10 mil, I'm going to change the size very quickly, make it 80 by 80 by 80. Now, if I pop that in there, there's no way I can see it. I don't know that it's in there. Make my life easier. I'm going to make one side 120. So I'm going to slide that through. And then I'm going to lift it 10 mil off the bed. I'm going to copy that, paste it, spin it around 90 degrees, basically go minus 90, push it through. Now I'm being very approximate here. Grab the same thing. This time I'm going to spin it 90 degrees the other way. Oops. Come on. There we go. And pop it in there. This one is going to have to go through a little deeper. Just make sure that whatever you're doing is actually centered. Select everything, group. I just sort of eyeballed it, so I actually ended up missing a bit at the back. You can see I've cut the back off. But it's literally me just inserting shapes into shapes and subtracting a hole from it.
It's positive and negative space.
That's about it. You want to build a wheel and an axle?
So I have a question just specifically about Tinkercad, because the last time I did an engineering drawing was 30 years ago, and there was a grey lead pencil and more erasers.
Yep.
Lots of erasers.
Yep.
In fact, lots of erasers. For someone if was going to venture down this rabbit hole, and I know AutoCAD's very, very sort of complex, but also very powerful, would Tinkercad be a good starting point?
It is, and I'm really glad you asked that question, because I'm going to flip back to Rob, who has done that exact thing. Okay. He started playing around with Tinkercad. I've shown you a very rough, I'm not a 3D designer, guys, I'm putting it out there. Rob is. Okay. Rob, all yours.
Okay, have you got me back again?
I've shown you. Yes.
Okay, so Praj, you're a real noob on that.
Yep, I know.
Could do better. Just laying out the inside.
That's why I've got him up there.
C minus.
Would not recommend.
That was a bit harsh.
Oh, no, I'm not a designer. I'm the first person to say that. I'm not a 3D designer.
Oh, no, you know Fusion.
Yeah.
And that gave me a pain in the brain, so I much prefer Tinkercad. Okay, so one of the first things that I ever built was this ladder. Oh, wow. And that was for a friend who had a model railway. And the next thing was this toothbrush holder for my toothbrushes. And then I also built buildings on the railway, so I made a window. And I've also made flywheels. And the other thing that I was doing at work was making parts for some of our equipment. So this item on the bottom right hand side is actually out of a Lufkin tape measure. And it keeps breaking when the students used to wind it crazily and whack it. And so I started printing those up. And because the tapes were about $80 each, and that was about 50 cents worth of resin. And I did that on resin printer. So the next few items that you'll see in my list here are a track switch, a steam engine, and a locking disconnect truck. They are complicated.
Oh wow.
So this is like a switching mechanism, and I've got two versions, one for filament and one for resin. The filament one is very basic, so it's to be printed on a flatbed, and so you can see these items here are printed on the flat, whereas over here on the resin, they're actually mounted upright. So this is the mechanism over here. This thing moves backwards and forwards and it moves the track. This is a steam engine. It's also made in Tinkercad. And I make it out of different pieces, and there's iterations of them all over, where I'm using them as working models. So not to screw things up, I keep them as a little bit of a backup. And this little black hole here is for a small bearing. This actually goes into my animated lumber mill at the moment. So it's kind of complicated. But you can also see that flywheel. I reused it. Animated better. And this is a logging disconnect truck. I'll show you the real item here, if you can see me on FaceTime.
Oh,
So
wow.
this is the tangible. And I've been selling those around the world too. So I made some of these people, and there was a guy in Wisconsin, and he said, "Hey Rob, have you got any logging disconnect trucks?" And I went, "I'll build you one." Only took about 2 or 3 months, but we got there. So that's pretty much Tinkercad. I'll just flick over to here. These are some of my Tinkercad designs. I've now got 185 of them.
Says Autodesk. Tinkercad.
Yep, Tinkercad's
One
on
thing
there.
I'm really worried about is them disappearing one day.
Bag of BS.
I hope it's never going to happen. But yeah, I've got a pile of things on here that I just keep for myself. I don't really sell them for anything. So pretty much, I think Praj, I think you're up next again.
Yep. Thanks, Rob.
Question. Steam engines, did they work? Compressed air?
No, but I could.
Okay.
It could work.
Thank you. There's another way of doing this that will actually let you go from 3D printing to working models. We'll come to that in a second.
Yeah, it is possible. These were designed, the second one, for my animated for my animated lumber mill. That's why I've got holes for bearings in there, and these things will go backwards and forwards, but I don't have pistons. It's just all faked at the moment. But anything's possible in 3D printing.
So I'm going to...
Okay, one of the other things, we were going to talk about the universe. Thingiverse.
Yes.
Have you all heard of Thingiverse?
Yep.
Yeah. Okay, so some of the things that I also sell are these little guys. I'm just going to pull one out of my cupboard here. This dude.
Oh wow.
He came from Thingiverse. The guy on the left. As you can see, he doesn't have a hat, and he's also got one leg up. So in Tinkercad, what I did, I chopped one of his legs off, copied the other one, and flipped it horizontally, and he's now got 2 legs, and he's sitting down. He's a bit of a lazy bugger. He's always sitting down.
Council worker.
Oh, he'll be sitting
also
down.
made him fat and a thin one. So, because they look a little bit better when they're fatter. Maybe a bit like me. So yeah, these are some of the things that I like.
Oh wow.
On Thingiverse. So this is my collection, and mostly figures at the moment. But I'll talk about these guys later because these are AI.
Wow.
Is everything on Thingiverse free, or do some people sell?
It's the license on them. You'll have to look at the license on each item.
Yeah, most of them are free.
All right, I'm going to very quickly transition to talking about the filaments that we use. Now, you've all seen TPU. You've all seen what TPU is like. Everyone knows PLA. PLA is just your run-of-the-mill made out of corn. That's carbon fiber infused PLA. Gram for gram, way stronger than standard PLA. That is a mini shin bracer designed by one of my year 9s.
Wow.
Is there a major difference in the material costs?
So PLA and things like PETG, by the way, there's a little carabiner on PETG, fully functional, fully flexible. It works in the sun. It actually doesn't take much UV damage. Does a really good job, except if you decide to leave it out there for a long time. At that point, you switch to something called ASA. Rob prints an ABS. I prefer ASA because ASA doesn't smell as bad. Has the exact same physical qualities as ABS.
Or AliExpress.
Or AliExpress. Look, I'm going to quote VK7TW here. I think Justin said this the last time I was here. The best 3D printer is a friend with a 3D printer.
Hey, that was Richard.
3D printing as a service.
You can print in PLA that shimmers. It's called PLA silk. Feel free to pass that around.
Yeah, Harry.
I've got silk. I've got silk as well. Yeah, I got a little special.
And all right, I'm going to reveal this a little early and pass it on to Lisa because she's got a second little module that needs a case. I've put her call sign on it. The material in the back is glow in the dark.
Oh, sweet.
So you're actually not going to lose it.
You will.
Oh,
Teachers.
That was the very last thing that showed up on 3D printing.
Peanuts are back at the front again.
So you got one for everyone.
I do, actually. So with that print, guys, it's the PLA bit is the glow-in-the-dark bit. The other side is PETG.
Yeah. Okay.
So PETG is the same material as your water bottles are made of. Very UV tolerant. Great little type of plastic.
Are your kids changing the nozzles to print this carbon fibre stuff?
We're just using hardened steel.
For everything?
Yeah.
Yeah, right, okay.
So I'm going to pass it back to Rob because he can tell you about how they survive, especially given we're all amateur radio operators. We need something that can survive outdoors. Rob's a specialist at that.
Oh, we lost him.
Rob, we've lost you.
No sound.
No sound.
Okay, that better?
Yeah, that's better.
Yeah, as Praj mentioned, a lot of my stuff I build for outside. I started with PLA and it lasted about a couple of weeks. And I used that when I was doing the FDM printing as prototyping because it's a lot cheaper than the ADS and the settings are a lot cooler. One of the things that Praj and I were talking about this afternoon is you've got to treat your materials with care. Because I've got this little example here. I've got a whole reel of black PLA. It just breaks.
Yeah.
Got one here.
You know,
Same thing.
Yeah.
it's so brittle. And that was because I didn't have it in my home-built humidity chamber. And it's got a little humidity meter on the top. And that keeps it from getting humid up in Queensland and disintegrating.
Can you recover it?
Now,
Yeah.
what was that?
Can you recover it?
Can you recover?
That's what people say that you can stick it in an oven and you can anneal it again and warm it up to high temperature without melting it, and that's supposed to do it. I haven't bothered yet because I'm not using my FDM printer very much at all because I couldn't. Okay. So what else are we going to talk about, Praj?
Oh, we're going to talk about layers, so I'm just going to pull that up for a second now. If I've got it here. I think I do.
Oh, that's the thing
Oh,
I was
yeah,
going to
it's
mention. I use ABS, as you said. Now, it's really hard to print ABS on a filament printer because you need seriously high temperatures on the bed.
That's
and there's
it,
lots of problems with PETG and ABS. I don't know about ASA Proj, whether it's, has problems lifting and things, but
It doesn't have the issues that ABS has. It's much better.
yeah, but we'll talk about that in a little bit more too.
All right. Thanks, Rob. Sorry. All good. So, guys, one of the things with 3D printing is you would have seen in the blurb that I sent through, it's all about the first layer. If your first layer adheres to the print bed, life is good. If it doesn't, it will break at some point. So, here's the first layer. It's got sparkly bits on it. I printed it on a nice smooth printer. And can you see the faults in the first layer? The little bubbles. It might look like a perfect print. Feel free to pass it around. As it starts to build layers up, it will start to peel. That, on the other hand, is a single perfect first layer. That's the size of my print bed. So that has no blemishes, that's not going to lift. Now, remember I was talking about how a 3D print is basically the first layer, top layer, walls, and the inside. So to give you guys an idea, these are the different patterns you can put onto your layers at different infill. Yeah. And that's the actual type of infill that you can put in.
Teacher's aid.
I'm going to pass this back to Rob so he can actually talk about how he does a 3D printing workflow. Anything you'd like to add about print structure, Rob?
Yeah, one of the little tricks I found for you guys is to use a circle when you're leveling your bed. I'm not as lucky as Praj. I don't have an auto leveling printer, so it's all manual. This little screw here, I have to adjust as it's printing. And with the humidity up here in Queensland, my printer is made of plywood. It tends to expand a little bit and contract. And so I sometimes have to level the bed maybe once or twice a week. So as I'm printing the circle, I'm watching how it's depositing the filament. And on the top one, it's too high. The bottom one is too low. And you'll actually hear your print head going in a ratchet mode. It's trying to force the filament through the print head, and it doesn't like it. And it goes da-da-da-da-da-da-da. And so in the middle one is what you're aiming for. A little bit of spread from the nozzle tip. And you just watch that until it goes around and around and around and you're happy with it. Yep.
All right. Now, the interesting thing is what happens when 3D prints fail, which is something we all have to be prepared for if we're 3D printing. Thank you. You get something that goes by the very tasty name of spaghetti.
We saw some examples of that last week.
Oh, that's the faulty one. Yeah.
Yeah.
Just feel it.
You basically get spaghetti when your print fails.
Yeah.
If you've got one of the modern printers, it's got a camera on it, it'll recognize that your print's gone sideways. It'll stop it. If you don't have one of the modern printers, you've got to go visually check it.
I reckon Greg wants a
Now,
3D printed.
Guys, there's something I'll pass around and you're welcome to take apart while Rob is talking. Here's a print head that failed because I had plastic melt through it, killing the thermistor, which means it can no longer read the temperature. Feel free to take it apart while Rob talks about how he sort of deals with print failures. Rob, all yours.
Print failures, yeah. Got my voice again?
Yep.
Okay, so print failures, as we've mentioned before about the bed coming, the print lifting off the bed, this is a common problem, and you basically need to make the brim around the print bigger, as big as you can get, especially with the high temperature stuff. Because the higher you get off the print bed, the cooler the print contact spaces. And this guy on the bottom right-hand side has actually used a very smart technique to save some filament, and he's actually using discs. One of the things I use to make my print stick is PVA glue. Praj and I was just discussing, he uses a glue stick.
Yeah.
But I use a diluted PVA, brush it on while the print bed is still hot. It dries fairly quickly, and it tends to stick quite well. So, and the other thing is, on your first layer, go as slow as you can. It basically fills in the base properly, and it gets a good adherence to the plate. And when you finish your print, let it cool. When I had a PETG print one day, I tried to remove it, and it actually took a layer of the glass off. Wow. It chipped the glass. So I learned my lesson.
So how do you change the speed on the first layer? Do you get into the G code and amend it?
I use Repetia host, and you can actually manually control the deposition speed and volume
on each layer.
As you're printing.
On each layer? Because you said you want to do the first layer slow.
Well, you can, that's a setting in Repetia print as well, but you can actually manually watch it, and you can change your deposition volume and your speed of print. And so I do the first one really slowly, and then I go back to default, and I'll go back to 100%. Yep.
Okay.
I'm just showing them on the slicer here how you can actually set the initial layer's speed, and then you can set the other layers.
Yeah, okay. Right.
So,
okay, cool.
All right. Rob, I'm just going to very quickly take you over to resin printing because that's your specialty, and given we're running out of time, I thought I'll let you go straight to resin printing and talk about what he does for outdoors resin prints. And the coolest thing, how he uses AI for printing.
Okay, so the dark art.
The dark art.
Let's shed some light on it.
More Sauron art.
So the pros and cons, as Praj mentioned, it can be complicated, but it's about the same learning curve as filament. Consult your forums, YouTube, and you'll have Praj as a mentor very shortly. He'll be local and on tap.
He did look impressed with that one.
3D printing as a service.
24/7.
Praj printing
as a service. The last present Praj before, and one of my the retirement present that I got, and Praj was very instrumental in doing that, was a Saturn printer. And it's hardly had a week off in 2 years. It's got a much bigger plate than the Mars. It's got the Wi-Fi, so you don't have to do the the SD card or USB card using SneakerNet. People know about SneakerNet.
Yes.
Oh, yeah.
It's a very 80s joke.
Yep.
Local file storage. So if you want to repeat a print, you can just go onto the printer and you can just go reprint. There's no magnetic flexi plate like the Mars, but I tend to get around that okay. The magnetic flexi plates, they actually adhere to the print plate via a magnet, and you can peel them off, and so you can just whack on your next plate and off you go.
Oh, yeah.
Oh, there you go. Thank you, Praj.
Okay.
How the workflow has changed, but it still stays the same. One thing you've got to think about is the angle that you're actually printing it and how you're going to slice it. Flat on the bed is not good, and I'll show you why. It tends to warp. This is so that's a piece of the truck that joins on there, and it tends to warp. And this is another painted version of it. And on this one, you can actually see how the
crack.
It's cracked.
Yeah.
And that is because I think that is a cheaper resin that I don't use anymore. So resins are very important. And you gotta, when you find a good resin, you stick with it. So as I said, flat on the bed, it's not really good. They tend to warp. Flat surfaces parallel to the plate also get a little bit of a light contamination. So when the UV is shining up, you get a little bit of reflection and it bounces onto the print and you get this really horrible finish. So yeah, flat surfaces are not good. So you've got to balance speed and angle, and that affects the final print speed. So the good, bad and ugly. Not all resins are equal, as I found out. I was using a brand I won't use, I will tell you about, that was going outside and it only lasted a couple of days. Trial and error, but I use now exclusively Sunloo, ABS-like, and I also add sometimes a little bit of Tenacious, which is another more expensive resin. But Praj showed me a little trick. You add 20% to your ordinary resin and it gives you more flexibility. Okay, and water versus alcohol wash. H2O sounds really easy, but as Praj and I both found out, H2O washable resin does not last outside very well at all.
Okay.
I found water washable doesn't last, but it was really easy to get rid of the liquid, of course, the liquid waste, because you could just evaporate it in the sun. I also invested in a wash tank, and I have two of them now. Now, Praj was mentioning you can make your own, but I actually splashed out and I bought two, and just the tank. The base has a timer on it, so you just set your timer, off you walk, and it's done. I did use a plastic tub and a magnetic stirrer. We had magnetic stirrers going up because we were throwing them away at UQ. Maintenance.
This is why resin printing is annoying.
There's very little maintenance you have to do on your printer. The only real thing you have to do is replace the FEP sheets every now and then. I just had to do one last month, and that's my second one in 2 years.
Right.
How I noticed that it was disintegrating was that when I was washing the resin out with some alcohol, the alcohol was actually going through to the underside of the section. So the resin wasn't going through, but the alcohol was. So I thought, time to redo it. The washing liquid and the cleaning and disposal of that washing liquid is a real pain. I'll get to that in a second. So some of the tools that I use are the scrapers, the metal scraper. That's to lift the print off the plate. The plastic one is to also lift. It's a little bit more gentle than the metal one. You don't use the metal one on your fat screen. And Praj also has the same thing, a little baker's spatula.
Yep.
That's very, very useful.
Very useful for mixing
You
resin.
can scrape excess. You can scrape the excess resin off your plate and let it drip into the tank. Now with the Sunloo filters, they come filters with the Sunloo. It's pretty handy. So these paper filters, you're disposable. I've got a metal one as well, but I hardly ever use that. And I use Mum's hairdryer. She nailed them beneath it, where she is. And the faucet, very, very handy. When you're pulling something off the plate, I've so many times dropped them with the plastic faucets. And these surgical faucets lock in place and they hold onto the sheet. So why I use those faucets is because I don't want resin dripping everywhere. So one of the key factors is ventilation. I have mine out in my workshop, it's outside. My wife walks in every now and then and she goes, "My God, it stinks out here." So I have this little ventilation fan on my wall right next to my ethanol tank, and that ventilates the fumes out. PPE, chemical gloves. They are very important, and especially elbow ones, especially when you're putting your hand into the ethanol tank. The nitrile works okay, but only for real fine dry work, not for the wet work. And I don't trust them. As Praj mentioned, you've got to keep your resin warm in winter, especially down in Hobart. He uses the brewer's pad. I use a reptile heat pad. I strap it onto the back of my printer and put some foam up against it and keep it going all night, keeps it nice and warm. And only in winter, that is. Mine, we had 34 degrees today, so I didn't have a problem.
Sure.
Avoid breathing the dust when you're sanding your print. I actually use a little spray booth, and I filter all the dust that goes through the spray booth, goes outside, because it's supposed to be inert, but don't trust it. Okay, cleaning the toxic waste. As I mentioned, 2 wash tanks. I have one that I sit down in the shade in my workshop, and I let all the resin and the very fine particulate matter settle out, and then I decant it. And I found this great device the other day, and it's a still. It's this red thing here. And what you can do with that is you can pour your ethanol into there, turn it on to 85 degrees, and you'll get pure alcohol out the bottom. I use ethanol from Bunnings. Yeah, you don't want to do your brew afterwards.
Who said brew?
Yeah, you can see there at the bucket on the right hand side. That is actually came out of absolutely clear ethanol. So that was still inside the ethanol. And so that's a bit of a sludge at the bottom. You've got to scrape it out at the bottom, and then you put it in the sun, let it cure, and then you can throw it in the bin. You don't have to worry about haz waste. So the plastic resin is very toxic, as Praj mentioned, and it's so toxic to wildlife, and it's also a microplastic. You don't want to have that floating around in the environment. And when you do have a spill, you wipe it up with some ethanol and a little curing chamber that Praj and I have got. He showed you that before. It's got a little wand, and it's got a UV light on it, and you can wave that around and on your bench. Don't do what I did one day. What I did, I took the top off the UV chamber, went go, and then walked out. And all the ethanol in my wash tank just went solid on one side. So I didn't do that again. But my table was nice and cured. Okay, cleaning failed prints. So this is a shepherd that I was making for some lady. She's into making nativity scenes and things. So this image in the middle, you can see it's a two-dimensional shepherd as opposed to the one down the bottom, which is three-dimensional. So what you have to do is you have to do the clean tank function on your printer, and that shoots up a lot of UV into the whole chamber, the vat, I mean, and then that cures. And then you take off the vat, you poke it with your finger and lift up one edge, get your forceps and lift it up, and then you just let that drip off and get all the resin off it.
Nice.
And as I mentioned, it's a good idea to, after a failed print, also filter your resin, just in case there's any small particles around. Yep. So, what's next? AI. This is some figures that I've been making.
Oh, yeah.
I'll just jump out to the website.
Wow.
So, this is me on ChatGPT. So I was showing this lady how to do it on ChatGPT, and I just said, nativity scene, shepherd standing. As you can see, it's a nativity scene with a shepherd standing. Okay, then I had to say, nativity scene, shepherd standing on a white background facing forwards alone. You need the white background because when you stick it into the next AI, it doesn't want any background distraction. So here he is, he's looking at me face on. Okay, then I went, okay, a new nativity scene, same shepherd, standing on the white background, facing forward, alone, carrying a lamb. Boom, there we go. So we've got a shepherd carrying a lamb. And I went, hey, no, I've already got one of those shepherds. I'll get another shepherd. So a new version of a clean-shaven nativity scene shepherd standing on a white background, facing forward, alone, carrying a lamb, looking down. And I thought, oh, hold on, he's got to look at Jesus. So we just start looking. Jesus.
God knows what AI thinks.
You bought the own.
Oh, I haven't got to the bordello yet.
No, don't do that. We'll get derated.
Demonetized.
So anyway, so this guy then goes into Tripo AI. This is another piece of software. I'll see if it renders. If it doesn't, I've got a little movie here too. There we go. Can you see that?
Mm-hmm.
Okay. He's got a lot of lipstick on. I'm not sure what the story is there. But anyway, so
that's the bordello.
Now from that 2-dimension into 3 dimensions.
Wow.
So what software is that?
Triple AI.
Triple
So
AI.
I've got this, yep. I'll give all these things to Praj as well. Now there's a really great YouTube video. How I got onto this, remember I said in Thingiverse, there was this whole thing of figures with AI generated. So I thought, I can do that. So I jumped onto YouTube, and there's this guy, he went through a whole bunch of different tools, and I just did it in one afternoon. So I used ChatGPT for the image creation, Tripo AI, or I've also now got a subscription to LightGen, which is my slicer. And another tool that I use is called Meshy, and that helps clean up hallucinations. Because I'll show you some of those in a second.
How do I apply that to my boss?
So here's some hallucinations. So this is one of the stokers that I made. He's got a big smile on his face. I had to tell ChatGPT to take the smile off. But as you can see, his shovel's got 2 sort of ends to it.
Oh.
So what I had to do is I took that shovel end into, at the stage, Tinkercad, and I squished it together, and I came out with a proper shovel. Now this guy, I then went to my advanced mode and I learned meshy. See how this guy here has his hands melded into the timber. So I tried unmelding them. That was too difficult. So what I did was I just took the piece of timber and his hands off using meshy. And meshy has these little plugins and it said hands. So I just slammed on a couple of hands and done.
Okay.
So you can cure hallucination. So this is my AI team. They are now in my animated lumber mill. And they're all being made with AI. And they're all painted up nicely there.
Beautiful. Thank you, Rob.
Right, there you go. No worries.
Thank you, Rob. If you hang around for a minute, there may be some questions. But before we switch over to questions, given we are in the Amateur Radio Club here in Hobart, I thought I'd do the standard teacher thing of going, I've got a pop quiz for you guys at the end. And I've got presents. So, it's a surprise set of presents. Why is PLA a terrible life choice if you were going to use it to build an antenna? Anyone?
It's going to degrade in high temperatures.
Degrades.
And
Well,
it's not suitable to weather outside.
So, what I'm going to do is I'm going to give you a PLA antenna mount. Don't use it outside. Question number 2. Plastic is not a conductor. Yep, we all agree.
True.
The microwave people in this room, check out 3D printing microwave horns on antennas. You can actually spray paint conductive paint on that and use them. Cool. I'll put a link up on Discord.
5KK does it with his 241 gig.
Yes, yeah, you can do that.
Is carbon fibre a problem?
No, it's not carbon fiber enough for it to be conductive. So
At microwaves?
even at microwave.
Okay.
Wow.
But if I were to build an antenna and then make myself a little, I don't know, antenna mass topper at a TPU, hook my antenna into that, antenna wire into that, do you reckon that's going to affect my antenna at all?
No.
Gold star.
Why?
It acts as a dielectric.
Okay.
So something to make a choke in. Made of PLA, don't use that outside.
Otherwise it'll choke.
Unless you paint it.
Yeah, true.
Weatherproof, yeah.
Okay, so since we can't use PLA outside, let's say you're using ASA. Yeah, lovely ASA that is outdoors robust. You print an enclosure, you put a mesh-tastic node up, print it in ASA. Works beautifully, and then suddenly stops. What's happened?
What does that mean?
No, it's pretty watertight and it's dimensionally very accurate.
So the printing stops?
No, you've printed it, you've made the enclosure, you've put your mesh-tastic node in there, you've put it on your roof, it works beautifully for a couple of days, and then it just stops.
Batteries.
Does it absorb water?
Nope.
You got hit by a cyclone?
Nope.
Lightning hit it?
Nope.
Make that nod.
I'll give you a clue. It has something to do with what happens when electricity runs through anything.
Oh, it melts.
Nope.
Carbonizes. Gets conductive.
Thermal management. Not a conductor. Heat gets trapped inside. Sorry, no one wins that. That's an Anderson power pole plate. All right, 2 more questions before we finish up. These ones have good prizes coming.
Can you use it outside though?
Oh, you can. You're printing a mount for a portable antenna, right? Do you optimize it for strength, weight, or do you go, that'll be fine?
Yeah, it'll be fine.
Depends on if you're doing powder or soda.
Yeah.
Especially in
I like the way
Tassie.
you think.
It's debatable.
I print about 20 copies. So, Puerto Real?
Sport tenor.
Spool tenor? So, Puerto Real?
You have to share
That-
the files.
Yeah.
She'll be right, mate.
That's Murray to a T.
Just
Okay. You print a part. It looks absolutely perfect. And then it just falls apart along the layer line.
Is a PLA.
No. This is something that Rob mentioned.
Is it your tank or your chamber not being at the right temperature? So the layers aren't adhering to each other.
The layers aren't adhering to each other. So there's two ways of doing that. You either fix the temperature or you change the angle at which things are being printed. Gold Star, you'll like this one, especially given your SOTA operator. You're going to have to wire this up to work the way you want it, but it's got all the components. That's a K6ARK mic in PEG.
Thank you.
It's got all the bits in it. You just need to wire it up to suit yours.
It's not more.
Nicely done.
I'll find a way.
Very last one, guys. My favorite question. What's the fastest way to go from a beautiful design to a failed print? I'll show you what the price for this one is.
Doing it yourself, not asking you to do it.
It's an Anderson Power Pole distribution box that takes a automotive blade fuse.
Disturbing it partway through the print job?
Nope. Sometimes that works fine. The QFH antenna is passing around. It's still operational.
Not applying supports to the
Nope.
file.
Not curing it.
Absolutely.
First layer.
What was the answer? Sorry?
First layer. Make sure that everything adheres to the bed. You can have the best possible design. If a corner lifts, it's wrong.
Yeah.
So what would you do if it does lift? You just go again?
You go again.
Go again.
And figure out why it's lifting and fix that.
Pass around.
All right. If anyone's got any questions, Rob's online. I'm here.
Cool. Can we show appreciation of Rob and Praj?